Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 1438, longest continuous subarray with absolute difference less than or equal to the limit. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking? That we are given a vector and a limit, and what we have to do is we have to find the longest subarray whose absolute difference is less than or equal to the limit. So what we are saying is, for example, if we take this subarray and we check the absolute difference between everyone, so 8 minus 2, 8 minus 4, 4 minus 2, we are taking absolute, so no worries about that. So here we are having a 6, a 4, a 2. It is all right, but 6 is greater than 4, so this subarray absolute difference is not less than 4, so we cannot take this. Let's take another size 3 subarray. 4, 7. 4 minus 2, 7 minus 4, and what else? 7 minus 2. It's 5, 3, and 2, but you can see this is greater, so we cannot take this also. Let's take this 4, 7. 7 minus 4, it's 3, it's less than. We have a subarray size 2. Let's take 2, 4. We have also less than or equal to, not equal to, less than 4. So this is also length 2. So what we would return, the maximum length is 2, so we will just return the 2. I hope this much is clear what we are doing. So let's see. Should it be done pairwise? Is it good that we do the difference pairwise and check one by one? I think it is not. What we can do is, for example, this is a subarray. It has certain elements in it, so we find max from it, we find a min from it, and what we do, we take their difference and see, check if it is less than or equal to the limit. Why we are doing this, and why this will point that this is the good subarray that we require? Because the best contender that can surpass the limit is this one, and the best contender that can help him or her, whatever it is, to pass the limit is this. We have to minimize this and maximize this. But if this, after doing subtraction, if it is less than or equal to the limit, what it means, that these were the best contender that can surpass the limit, but they were not able to, so no one can. And if it is still not clear, make a number of test cases and then see for yourself. But this is true. If this is the maximum difference, max difference that you can find from this subarray, and if this is less than the limit, then what else can be done? I hope this much is clear. So what we have to do, we have to find the max and min. But if we just simulate this approach of max and min, it is around O of n square. but we can do something better in this. What it is? We are finding max and min of subarray. Max and min of subarray. Which data structure can get us max and min? Which data structure can get us max and min in log n? Sorry. With the by using log n of time complexity. I would say min, not min heap, priority queue of min heap and max heap type. Why max heap? To get max. Why min heap? To get minimum. I hope this much is clear. Why priority queue is used to get the maximum and minimum in log n, and our time complexity will reduce down to log n. Log n, sorry. Let's see. The algo. How are we gonna do this? First is traverse by using 2 pointers. We will be using 2 pointers. Okay, this much should be clear. Now let me give the explanation why we are using. For example, if we have I over here and j over here, so first of all, these two are used to identify which subarray we are on. And other thing, for what is the other significance of I is that using the I, we will know which elements should not be present in the min and the max heap, because these will not influence the difference, because these are not the part of subarray. So that's why we are using I and j. I hope this much is clear. And next thing we will be doing is checking if the min and the max heap contain, sorry, it will be a third step. Second step would be push the current in min and max heap. On which data we will do computation if we do second step checking? So first put the data, then check. So we put the data, push that inside the min heap and max heap, and then check if it contain what, index less than equal to I. If it contains, pop them. Basic thing. Now last thing, most important, what we do? We have a min, we have a max. What to do? Check, is it less than or equal to the limit? Max minus min. Check if it is less than or equal to the limit. If true, it is less than or equal to the limit, what we do? Calculate the length. How we calculate the length? Length max. This is trivial stuff. What else if not false? This is not true. What we have to do? If, let me again make this for you. If this is our subarray, I is pointing to this element, and j is pointing to this element. So what we will do? If it is less than, not less than, greater than the limit, we have to remove we have to remove from the start, because we don't know. We will just remove from the start, as you usually do in sliding window kind of approach. We just remove from the start. We remove from the start. Now I is pointing over here. I is pointing over here, and after that I is pointing over here. What we will do, we will push the next current elements, and what else, we will check for the elements that are no longer the part of this Subarray, as you can see this part. So we will remove them and again compute if it is less than or equal to the limit, and this keeps on going till it's traversed the vector. So let's check the coding part, and then we will dry run it to have more understanding. So yeah, this is the max heap, this is the min heap, this is basically priority queue of max and min. And why we are taking this int comma int pair, because this will store nums I, this will store the index. Why we need index? Because you know how we gonna do that, do the check that this I dash is less than I. So that's why we are storing it, to have our indexes. Yeah, this much is clear. Our first pointer, our result, we are finding max, so that's why we are storing min. Our second pointer, traversing, pushing the data inside max heap and min heap, and then checking if it does contain anyone that whose index is less than I. If it is pop, same thing happen with min heap. And what we are doing over here, if the max and the min is greater than the limit, what we do, we discard, we decrease the size of the window, and for that we increase I plus plus. And what we are doing over here, just basic thing, taking our account of array, not array, sorry, length. That's it. That's what we are doing over here. And let's have a dry run, quick dry run, to have a more clarity. Where is our test case? This is our test case. Let's quickly paste it over here. Yeah, eight 247, and limit is what it is, 4 0 1 2 3. I is over here and j is over here. Okay, now this is max heap, min heap. So first 8,0 is pushed, 8,0 is pushed, and we check if currently I is 0, I is less than or equal to I is less than 0. And what index we are having over here? 0 0. No, they are equal. Then what we check, if the min and the max, is it greater than the limit? 8 minus 8, is it greater than the limit? No. Then what we do, we take the length, so over here j is 0, I is 0, and plus 1, so result is storing 1. This much is clear. Now j is over here, j is over here. Yeah, j is over here. Now you push 2, 2 comma 1, 2 comma 1. Which one is min or which one is max? Let's take this as min and this is max. 8 comma 0, 2 comma 1. Now we will check less than 0. 1 is not less than 0 and 0 is not less than 0. These two conditions will not be executed. We are at this. Now what we do? 8 minus 2, 6. Is it less than limit? No. What we do? We increment. Now I is over here, and again we calculate j is 2, I is 2 plus 1. Still result is 1. And what happens over here? Now first j is now over here. 4 is pushed. 4 comma what it is? 2. 4 is pushed. 4 is pushed. Now what I is pointing to? I is pointing to 2. Carefully check this condition. Carefully check this condition. I is not pointing to, I is pointing to 1. Sorry, not pointing to 2, 1. My bad. This is the index. These are the index. Let me highlight it. I is pointing to 1. Now I is pointing to 1. Is it less than 1? No. Is it less than 1? This is max, this is min. This is less than 1. So this will be popped out. And now again this line is executed. We again check what is the top. Again? Did I pushed 4? Yeah, I pushed 4. Yeah. So what is the max? Currently 4. What is the min? 2. It's 2. Is it less than 4? Yeah, it is less than 4. Now j is at what? 2. J is at 2. I is at 1 plus 1, 2. This is now updated to 2. Result is now 2. Now j is over here. Again 2, 1, 4, 2, 7, 3, 8, 0. 7 will be at the top. This is 2, 1, 7, 3. 7, 3. And what else? 4, 2. And what was at the bottom? 2, 1. Yeah. And we can see I is 1. Is 1 is less than 1? No. 3 is less than 1? No. Now we are at that condition. Max minus min, 10 minus 2, 5, and it is greater than 4. What we do? I is equals to 2 this time, and after that I is equals to 2 this time. 3 minus 2, 2, but still we have 2, nothing updated, and j points to 4, and we get out of this for loop. And what we return? 2 is written, and 2 is the output also. And let's submit it. and see if it is submitting or not. Yeah, it is submitting. I hope you get the intuition, you get something to learn, and consider subscribing to the channel if it did help you in something, and liking this video. And you have to do what you have to do, so keep grinding. And also there is O of n approach using what it is, Q, monotonic Q. So that I will discuss in another video. So that's I wanted to talk. So keep grinding. You guys are awesome. See you in the next one. Bye bye. And consider subscribing and liking this video. See you in the next one. Bye bye.